Hello students, in today's class, let us derive the equation of the plane passing through the intersection of two given planes. So here, you can see there are two planes, pi 1 and pi 2. And the third plane, which we have considered as pi 3, is passing through the intersection of these two planes. So, if I take this book, and the right hand side of the right hand side part of this book will be considered as pi 1 and the left hand side will be considered as the plane pi 2. Now if I hold a page, so this will be the plane pi 3. So if you can see, there is a line here and this is the line of intersection of two planes. So this page which I am holding now, this will be your plane pi 3 and this is passing through the intersection of two planes. So let us derive what is the equation of the plane pi 3. So here let pi 1 and pi 2 be the two planes with equation vector r dot n1 cap is equal to d1 and vector r dot n2 cap is equal to d2 respectively. Now I am going to consider any one point on this line of intersection and the position vector of this point will satisfy both the equations of the plane pi 1 and pi 2. Okay, so there will be infinite number of the points on this line of intersection. So I will be considering only one of them. So one point I am going to consider and that point's position vector will definitely satisfy the equation of both the planes pi 1 and pi 2 as this line of intersection belongs to both the planes pi 1 and pi 2. Therefore, the position vector of the point on the line of intersection must satisfy both the equations. Okay, so let us think. We have considered one point and that position vector, I'll call it as T. So let vector T be the position vector of the point on the line of intersection. So as I have already said, this position vector will satisfy the equation of both the planes pi 1 and pi 2. So from that I can write now the equation vector r dot n1 cap is equal to d1, which is the equation of the plane pi 1, and vector r dot n2 cap is equal to d2, which is the equation of the plane pi 2, can be written as vector t dot n1 cap is equal to d1 and vector t dot n2 cap is equal to d2. Now, therefore, for any real value lambda, we have, since this point which belongs to both the plane pi 1 and pi 2, now I can write this as vector t dot n1 cap plus lambda times n2 cap is equal to d1 plus lambda times d2. And here t is an arbitrary. Now since vector t is arbitrary, it satisfies for any point on the line. Hence, the equation of the plane pi 3 will be now written as, hence, the equation of the plane pi 3 will be given by vector r dot n1 plus lambda times n2 vector is equal to d1 plus lambda times d2. And this is the vector form of the equation of the plane which is passing through the intersection of two given planes. Now let us see what is its Cartesian form. Now let's derive its Cartesian form. So for this, let vector r be equal to xi cap plus yj cap plus zk cap, and vector n1 is equal to a1i cap plus b1j cap plus c1k cap, and vector n2 is equal to a2i cap plus b2j cap plus c2k cap. Now let us substitute these values in equation number 1. So the vector form I am going to consider as equation number 1. So we are going to substitute these values in equation number 1 and find its Cartesian form. So substituting all these values in equation number 1, we get, so vector r, which is xi cap plus yj cap plus zk cap dot, next we have vector n, which is a1i cap plus b1j cap plus c1k cap plus lambda times n2 vector, which is a2i cap plus b2j cap plus c2k cap is equal to b1 plus lambda times b2. Now, xi cap plus yj cap plus zk cap dot. Now let us add this by first multiplying lambda to the second vector, that is n2 vector. After that, we add all the like terms. Here the like terms are those which is having I cap, j cap and k cap. So first we are going to add all the I cap terms. So now when we add, we get a1 plus lambda times a2 into I cap plus b1 plus lambda times b2 into j cap plus c1 plus lambda times c2 into k cap, which is equal to b1 plus lambda times b2. Okay, after this, now let us find the dot product between these two vectors. So if I find the dot product between the vector, we know that xi cap dot a1 plus lambda times a2 into I cap will be equal to x into a1 plus lambda times a2, because I cap dot I cap is equal to 1. Next, similarly, next if you find the dot product between xi cap and b1 plus lambda times b2j cap, then I dot j will be equal to 0. Therefore, that we are not going to write. The remaining terms let us write. So next it will be yj cap dot product with b1 plus lambda times b2 into j cap. So that will be equal to 1 into b1 plus lambda times b2. Similarly, z into c1 plus lambda times c2 is equal to b1 plus lambda times b2. So now after this, let us multiply this x inside. So we get a1x plus lambda times a2x plus b1y plus lambda times b2y plus c1z plus lambda times c2z is equal to d1 plus lambda times d2. Now, what I am going to do is, I am going to group the non-lambda terms as one term and the lambda term as the other one. So here we get a1x plus b1y plus c1z, and I am even including this term in the right hand side, that is b1, which is a non-lambda term, minus b1, Next plus, now we are going to group the lambda terms where I am going to take the lambda common. So lambda common, so we get it as a to x plus b to y plus c to z minus d2 is equal to 0. And this is the Cartesian form of the equation of the plane which is passing through the intersection of two given planes. This is the Cartesian form. Vector form is vector r dot n1 vector n1 plus lambda times vector n2 is equal to d1 plus lambda times d2, and Cartesian form is a1x plus b1y plus c1z minus d1 plus lambda times a2x plus b2y plus c2z minus d2 is equal to 0. Now let us solve the problems of this. Okay, first problem, find the vector equation of a plane passing through the intersection of the planes. Vector r dot 2i cap plus 2j cap minus 3k cap is equal to 7, and vector r dot 2i plus 5j plus 3k is equal to 9, and through the point 2, 1, 3. So this is the equation of the two planes pi 1 and pi 2. They are given in the form vector r dot n cap n1 cap is equal to d and vector r dot n2 cap is equal to d. So first let us write this vector form into Cartesian form. So this equation, writing in its Cartesian form, we'll get it as 2x plus 2y minus 3z is equal to 7. And for the plane 2, this I am writing it in Cartesian form. So it will be 2x plus 5y plus 3z is equal to 9. Here we need to find the vector equation of the plane. In order to find the vector equation of the plane passing through the intersection of the two given planes, first I am going to use its Cartesian form. So using Cartesian form, we'll derive the equation, then we can write it in vector form. So we have already studied what is the Cartesian form of the equation of the plane passing through the intersection of two given planes. That is ax plus by plus bz is a1x plus b1y plus c1z minus b1 plus lambda times a2x plus b2y plus c2z minus d2 is equal to 0. So now this will be equal to 2x plus 2y minus 3z minus 7 plus lambda times 2x plus 5y plus 3z minus 9 is equal to 0. And they have given that this is passing through the point 2, 1, 3. So since it is passing through, since it is passing through the points 2, 1, 3, we can substitute x as 2, y as 1 and z as 3 in this equation in order to find the lambda first. So substituting x as 2, y as 1 and z as 3, we get 2 into 1, 2 into 2, x is 2, therefore 2 into 2 it is 4, then y is 1, 2 into 1 it is 2, minus 3 into z value is 3, 3 into 3 is 9, minus 7 plus lambda into, again 2 into 2 it is 4, then plus 5 into 1 it is 5, then plus 3 into 3 9, minus 9 is equal to 0. Therefore you have minus 3 minus 7 minus 10 plus lambda times 9 is equal to 0. Let us find the lambda. Therefore lambda is equal to 10 by 9. Now you substitute this lambda value again in this equation. So I'll be writing this, I'll be considering this as equation number 1. Substituting lambda is equal to 10 by 9 in equation number 1. We get 2x plus 2y minus 3z minus 7 plus lambda is 10 by 9 into 2x plus 5y minus 3z, so plus 3z minus 9 is equal to 0. Now taking the LCM and simplifying, so LCM here is 9, So when I take the LCM, this becomes 9 into 2x plus 2y minus 3z minus 7 plus 10 into 2x plus 5y plus 3z minus 9 whole divided by 9. Then cross multiplying 9 to the right hand side. 9 into 0, 0. So you will get this as 9 into 2x plus 2y minus 3z minus 7 plus 10 into 2x plus 5y plus 3z minus 9 is equal to 0. So multiplying this, you'll get this as 18x plus 18y minus 27z minus 63 plus 20x plus 50y plus 30z minus 90 is equal to 0. Let us simplify further. So you have 18x plus 20x, therefore that will be 38x. Then you have 18y plus 50y, that will be equal to 68y. Next, you have minus 27 plus 30z plus 3z minus 63 minus 90, it will be equal to 153 is equal to 0. Therefore, you have 38x plus 68y plus 3z is equal to 153. And this is the Cartesian form of the equation of the plane passing through the intersection of two given planes. But they have asked for vector form. So writing this in the form of vector, you will get as, so I conclude here. So writing this equation in the vector form, we have vector r dot 38 I cap plus 68 j cap plus 3k cap is equal to 150. Next problem of the same kind, but here instead of giving the vector form, so in the previous problem you have seen they have given the equation of the two planes in its vector form, but here they are directly given in its Cartesian form. So let us first write the Cartesian equation of the plane passing through the intersection of two given planes, and it is given by a1x plus b1y plus c1z minus b1 plus lambda times a2x plus b2y plus c2z minus b2 is equal to 0. So the first equation you should write here. So the equation is 3x minus y plus 2z minus 4 plus lambda times you have x plus y plus z minus 2 is equal to 0. Okay, now what you should do? They have given that it is passing through the point 2, 2, 1. So since it is passing through the point 2, 2, 1, now we should substitute x as 2, y as 2 and z as 1 in the above equation. So substituting 2 into 3, 6 minus y value is 2, then plus 2 into z value is 1, so it is 2, then you have minus 4 plus lambda times x is 2, y is 2, z is 1, and you have minus 2 is equal to 0. Simplifying to find the value of lambda, so it will be 6 minus 4, it is 2, then plus lambda times, here you have 2 plus 1, 3 is equal to 0. So what is the value of the lambda? So lambda will be equal to minus 2 by 3. So calling this as your equation number 1. So substituting lambda is equal to minus 2 by 3 in equation 1 you get, so you have 3x minus y plus 2z minus 4 minus 2 by 3. So lambda value is minus 2 by 3. So plus of minus 2 by 3 will be equal to what? Minus 2 by 3 into x plus y plus z minus 2 is equal to 0. Now the next step is to take LCM. So taking LCM, we get 3 into 3x minus y plus 2z minus 4 minus 2 into x plus y plus z minus 2 is equal to 0. Whole divided by 3 you will get, as the LCM is 3. So that 3 which is dividing here will be multiplying with our RHS, which is 0. So 0 into 3 will be 0. Then you get this step. So now multiplying 3 inside, so we get 9x minus 3y plus 6z minus 12, then minus 2x minus 2y minus 2z plus 4 is equal to 0. Simplifying 9x minus 2x, 7x minus 3y minus 5 minus 2y minus 5y plus 6z minus 2z plus 4z, then minus 12 plus 4 minus 8 is equal to 0. Therefore, the Cartesian form of the equation of the plane passing through the intersection of the two given plane is this. Here, if they have not mentioned vector form or Cartesian form, you can just leave it here. If they mention which form of the equation they will require, this is the Cartesian form. So in order to write its vector form, we write as vector r dot 7i cap minus 5j cap plus 4k cap is equal to 8. Okay, let us take up the next problem. Next problem. This is a similar problem which we have already done 2 problems of the same kind, and this I am going to give you as homework. So here they are given in vector form. First you should write it in its Cartesian form. So the first Cartesian for the plane one, the Cartesian form is x plus y plus z minus 6 is equal to 0, and the second plane you have 2x plus 3y plus 4z plus 5 is equal to 0. This you should substitute in the place of a1x plus b1y plus c1z minus d1, and this you should substitute in the place after lambda. What we are going to write it as a2x plus d2y plus c2z minus d2, and simplify further. Find the value of lambda. After finding the value of the lambda, substitute in the first equation so that you get your Cartesian form. After getting its Cartesian form, you can easily write it in its vector form. Now next problem. Find the equation of the plane through the line of intersection of the planes x plus y plus z is equal to 1, and one more equation of the plane they are given, 2x plus 3y plus 4z is equal to 5. Both the equations, that is the plane 1 and plane 2's equations, are given in its Cartesian form, which is perpendicular to the plane x minus y plus z is equal to 0. The only difference between the last 3 problems and this problem is, in all the 3 problems, they are mentioning the points through which point it is passing. But here, instead of mentioning the points, they have given the other clue, that is, which is perpendicular to the plane x minus y plus z is equal to 0. Let us see how to solve this problem. So, as they are given in its Cartesian form, first let us write the equation of the plane passing through the intersection of 2 given planes in its Cartesian form. And it is given by a1x plus b1y plus c1z minus d1 plus lambda times a2x plus b2y plus c2z minus d2 is equal to 0. So first substitute this in the place of this. So it will be x plus y plus z minus 1 plus lambda times 2x plus 3y plus 4z minus 5 is equal to 0. Now after this, what you should do is, we should add the terms. Here, adding the common terms, that is x with x. So when I add this by taking x common, if I am adding, I get, what is the coefficient of x here? It is 1. Here, the coefficient of x becomes 2 lambda. Okay. Another step, let us simplify. X plus y plus z minus 1 plus, I am multiplying lambda inside, 2 lambda x plus 3 lambda y plus 4 lambda z minus 5 lambda is equal to 0. So now let us add the like terms. So adding the like terms by taking their common. So here x and x term are going to add. The coefficient of x here is 1 plus 2 lambda, and I have taken the x common. Next, similarly, we have 1 plus 3 lambda y plus 1 plus 4 lambda into z. Then we have minus 1 minus, sorry, here we should even multiply lambda for 5. So minus 5 lambda is equal to 0. Therefore, we have minus 1 minus 5 lambda is equal to 0. After this, we write it as 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 plus 4 lambda into z is equal to 1 plus 5 lambda. Now, let us use the condition given here in order to find the value of lambda. In the previous problem, we used to substitute the points in order to find the value of lambda. Here, we are going to use the condition, that is, these two planes are perpendicular to the plane x minus y plus z. So, the condition here is, if the two planes are perpendicular, if two planes are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Remember this, if the planes are perpendicular, if the two planes are perpendicular, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So what is your a1 here? The coefficient of x is your a1, coefficient of y is your b1, and coefficient of z is your c1. And what is a2, b2, c2? Those are the coefficient of this plane, because now this plane is perpendicular to the plane x minus y plus z. So I am considering this as our plane 1 and this as our plane 2. So the coefficient of x, y and z are the a1, b1 values of the plane 1, and here the coefficient of x, y and z of this plane are a2, b2 values. So here a2 value is 1 because coefficient of x is 1, b2 value is minus 1 and c2 value is plus 1. So according to that, am I clear? I hope I'm clear with this. What are the values of a1, a2, b1, b2 and c1, c2? So a1, which is 1 plus 2 lambda into a2. a2 is the coefficient of x here and it is 1. Then plus b1, coefficient of y of the first plane, 1 plus 3 lambda into b2, the coefficient of y of the second plane, which is minus 1. Plus next c1, 1 plus 4 lambda, c2, which is the coefficient of the second plane, which is 1. Coefficient of z in the second plane. So 1 plus 5 lakh. So is equal to 0. According to the formula, this is equal to 0. So simplifying further, let us multiply 1 inside. 1 plus 2 lambda. We are multiplying minus 1. We get minus 1 minus 3 lambda. Next multiplying 1, we get 1 plus 4 lambda. So plus 1 minus 1 get cancelled. You have 1, then 2 minus 3, 2 lambda minus 3 lambda minus 1 lambda, minus 1 lambda plus 4 lambda. It will be plus 3 lambda is equal to 0. So the lambda value is minus 1 by 10. Now substituting this lambda value, same way. So there we will be able to find the value of lambda using the points. Here now we are able to find the lambda values using the given data. So after finding the lambda value, what we should do? We should substitute back in the equation. So this is our equation 1. So substituting in equation 1, we get, so 1 plus 2 into lambda value is minus 1 by 3. I am doing it directly. 2 into minus 1 by 3, it will be equal to minus 2 by 3. So 1 minus 2 by 3 into x, next plus 1 plus 3 into minus 1 by 3, it will be 1. 3 into minus 1 by 3, it will be minus 3 by 3 into y, then plus 1 plus 4 into minus 1 by 3, it will be equal to minus 4 by 3 is equal to 1 plus 5 into minus 1 by 3, it is minus 5 by 3. So the last step, I am going to write it here. So 1 minus 2 by 3, the LCM will be 3, therefore it will be 3 minus 2 whole divided by 3, 3 minus 2, it is equal to 1. So you get 1 by 3 into x plus, see here 3 by 3 is 1, so 1 minus 1 is 0, so you get 0y. Next you have LCM is 3 again, 3 minus 4 whole divided by 3, 3 minus 4, it is equal to minus 1 by 3 into z is equal to, here it will be 3 minus 5 divided by 3, 3 minus 5 is minus 2 by 3. So what is the LCM in the left hand side? LCM is 3, so we get as x plus 0y minus 1z divided by 3 is equal to minus 2 by 3. I am neglecting the 0 into y, therefore we get 3 and 3 get cancelled. X minus z is equal to minus 2 or x minus z plus 2 is equal to 0 is the equation of this plane. Understood?